Hello, this is Maria from mathmammoth.com. In this lesson, we're going to look at translations in the coordinate grid. Here I have an example triangle, and as I move it or translate it a certain distance here and there, we need to especially notice the coordinates of the points that are moving, or the coordinates of the vertices, to be exact. So if I move this triangle, notice that point A is here at 1, -1. If I move this triangle, say 1 unit over here, now point A is actually 2, -1. I moved it 1 unit to the left, and now point A has 2, -1. I know it doesn't read that way, but you have to imagine. If I move it 2 units more here, then point A is actually at 4, -1. So this x-coordinate gets incremented by however many units I move it to the right. And if I move it to the left, let's say I move it this many units to the left, then point A is actually at 0, -1. If I move it to the left some more, the x-coordinate will get smaller, that many units. If I move it up or down, then similarly the y-coordinate will start changing. Here, point A, y-coordinate has become now 0, not -1 anymore. And if I move it, let's say over here, now the y-coordinate here is actually -3. It is 2 less than what it used to be, since I moved it 2 units down. Okay, let's say that I move it over here. What kind of movement was it? Point A has moved to A prime over here, and so it moved 1, 2, 3 units down, and 1, 2, 3, 4, 5, 6 units to the left. 3 units down means that this y-coordinate is going to be 3 less. It's going to be -4. And indeed it is, -4. And then 6 units to the left means that this number, the x-coordinate will be 6 less. 1 minus 6 is -5. And yes, the x-coordinate is now -5. A triangle was moved 6 units up and 2 to the left. Now its points are at 5, 4, -3, 7, and 0, 6. What were the coordinates of its points before the translation? We can now solve this problem without using a grid. We can just calculate. Because when it says 6 units up, and we know the coordinates of the points after that movement, then we can move things 6 units down to go to the original, or subtract 6. And then 2 to the left, that has to do with the x-coordinate movement. Its movement was, if it was somewhere here, it moved 6 units up and 2 to the left. So therefore, we will move it back 2 to the right, or add 2 to the x-coordinates, and subtract 6 from the y-coordinates. Then we will get the original points. So for the first point, we have 5, 4, and 4, we will subtract 6 to get what the y-coordinate was originally, so it was -2. And 5, we will add 2 to get where it was originally, 7, -2. Then the next one, 7 is the y-coordinate, we subtract 6, so we get 1. And then -3, we add 2, so we get -1. And then the last one, 6, we subtract 6, we get 0. And then 0, we add 2, we get 2. Those are now the coordinates of its points before the translation. Calculations was sufficient, we didn't need a grid. Lastly, how would you prove that those two figures are congruent? We're going to use congruent transformations to do that. So this is actually very easy. All we need to do is list which particular congruent transformation maps figure 1 to figure 2, and then we're done. Because each congruent transformation preserves congruence. And here, it's a case of a translation, right? The figure just has been moved. All we need to do is specify which particular translation was it, how many units, and where. Let's look closer. If we look at, for example, this point here, it is right now, the x-coordinate is -2, and it becomes 6. So therefore it moved 8 units to the right. And then the same point right now, the y-coordinate is 0, and it becomes -3. So it moved 3 units down. This is specifying that it was a translation where the figure was moved 3 units down and 8 units to the right is sufficient for the proof, and mentioning that it is the translation, and the translation is a congruent transformation. Okay, we're all done, and I hope this was helpful.